in a position where you're asked, and then just to simplify things, imagine that to first order approximation, you're just going to spend the money when you get it. Okay, so what I'm actually talking about is your consumption utility at any point in time. All right, everybody have a sense of their answer? Supposed to be able to just look inside yourself, calculate your utility function, and pop out a number? Because that's how human beings work. All right, let's do group one first. Go ahead and click in your answer. Okay, 3, 2, 1, and there are not that many of you in group one. There really can't be. Okay, let's do group two. Go. Is it the slightest possibility that anyone at first thought they were in group one and were actually in group two? No? Anybody? That's a weird imbalance. I have a feeling that the work studies in the econ department got my copy job wrong. Okay, we're done? 79 of you? Fine. All right, now I will expose what's going on here. The first group overwhelmingly said B, and that is what I expected. No, it isn't. Sorry, let me just get the comparison on the table. So what happens here is a bunch of people say A in group one, and that's group two? Oh, okay, yeah, okay. So majority of people in group one said A, big change, majority in group two said B. Let's take a look at what the actual differences are. Group A was faced with $100 today versus 105 in 2 weeks. Okay, so now is involved. And group two was faced with a different question, which was $100 in 52 weeks, $105 in 54 weeks. Same delay, 2 weeks delay, same dollar values. One of them, there's now implicated in the question, and the other one, they're all in the future. And you see this massive change in preferences, okay? And as usual, you guys are extremely good guinea pigs. That's exactly the way this is supposed to work. And I wrote these words that aren't in your handout because I didn't want to lead you in terms of how to think about this. This one we can think of as a situation where there's temptation involved, right? Things now tend to be tempting, right? Am I right? You with the sprite? It's tempting right now. This one we can think about as an example where because the outcomes are all in the future, it's easier for you to implement kind of prudence, patience. So we call that a preference reversal. Not surprising that that's one of the first things we look at. That's an anomaly. So what I'm going to show you now is, right, I'm going to take those results back to the standard model, the Samuelson model, and I'm going to show you mathematically how that anomaly violates the model and cannot possibly fit the model. Okay, so under discounted utility, your preferences over delayed outcomes should not change over time. Okay, where the delay doesn't change and the outcome doesn't change, your preferences shouldn't change. So time periods are going to be defined in terms of 2-week periods. So delta now is the 2-week discount factor. And I've left out 0 here. I didn't mean for that to be any different than usual. Okay, so delta, right, so the first thing you do in modeling is you define the time period. In this case, it's 2 weeks. Suppose that you prefer $100 now over $105 in 2 weeks, as 51% of you did. What must be true about your value of delta? And it goes like this, right? We compare the utility of getting, and that's the little u, because there's only one time period in each of these plans, so we don't have to do a whole big summation. It means that the instantaneous utility of $100 now, right, with that's delta to the 0, is greater for you than delta, which is d of 1, the discount factor for 1 period ahead, times the utility you get for $105, which implies that delta is less than the ratio of the utility you get out of 100 and the utility you get out of 105. Now, if we want to make the assumption of linear money preferences, we could just say that's 100 divided by 105, and we'll do that in a little bit, but we're not going to do that right now. We're going to leave it in utility terms. Okay? If that's true, if the discounted utility model is correct, and we apply it to your preferences in group 1, this mathematical statement must be correct. If that's the case, what must be true about the choice that you were asked to make in group 2, where everything's delayed by a year? Okay, so what we get is this. The way we represent your preferences is delta to the 26, which is 52 weeks from now, times the utility of 100. Is right, so that we're asking the question. I've never known quite how to notate this. Like, is this greater or lesser? I do it that way, just greater or less with a question mark. Okay, so that question, right, which is greater, delta to the 26 times u of 100, delta to the 27 times u of 105. That is equivalent to asking the question, right? Just strike all of that and the 27 here, right? We just divide everything by delta to the 26. That's equivalent to the question whether u of 100 is greater than or less than u of 105. And that's equivalent to asking the question of whether delta, sorry, I'm not going to flip it around yet because I want the direction to work, whether this ratio, u of 100 over u of 105, is less than or greater than delta. Okay? Now, we know, based on the discounted utility model, that delta is less than u of 100 over 105, which must mean that you value u of 105 times delta to the 27 less than delta to the 26 over u of 100. So if the discounted utility model is correct, if you chose $100 now over 105 in 2 weeks, right, if this was the one you liked, then it must also be the case that you chose 152 weeks over 105 in 54 weeks. And you didn't on average. Okay? Thank you. Right here. Thank you. Does the math make sense? The absolute key to the exponential discounting model is the fact that the discount factor from one period to the next is always delta. Okay? Which means that you take any 2 periods that are the same distance apart and put them now, later, much later, and how you feel about those 2 periods relative to one another is always going to be the same because you can always just divide off a whole chunk of deltas, like we just did. So this is absolutely crucial to the expected utility model. You get this time consistency because the per period discount factor is always the same over time. Okay? And that's going to be the essential thing that we're going to look at over and over again. And then, of course, we want to say what happens if, in fact, we observe you choosing 105 and 54 weeks instead of 152 weeks, and you won't be surprised that what that implies in the model is that delta to the 26 times u of 100 must be greater than delta to the 27 times u of 105, and you can see that that implies that your delta must be greater than u of 100 over u of 105, which is directly contradictory to what the model told us about your first set of choices. Okay? So we have a preference reversal. That's no good. We have the implied delta, which is supposed to be constant, not being constant. We have big problems. No, I think I got it. I don't know. I think it's right. I did the math earlier, so it's much more likely to be right than if I did it now. So basically what this says about you, and you guys, by the way, you guys are perfectly normal. Everybody's like this. What it says about you is that, in fact, your per period discount factor is much smaller when now is involved, and much much bigger when later is what we're talking about, right? You guys discounted that delayed $105 much less when both outcomes were way out in the future. So we're going to find that representing delta as constant is no good. More generally, the discounted utility model, Danielson's model, predicts time consistency over all future outcomes. Okay? So first let me define what I mean by time consistency. Preferences are time consistent if and only if for any two plans, A and B, which differ beginning at some time period t. So these are plans that are the same up until some period of time. That if an individual prefers A over B at any point in time before t, they should also prefer A over B at time t, and vice versa. Right? So for any two plans that are the same up to a certain point in time, anywhere in that initial chunk where they're the same, it shouldn't matter when I ask you which of the two plans you prefer. Okay? So the simplest way to think about this is suppose you have two plans that are the same today, and then in the future they differ. So the only difference between them is that plan A and plan B they're the same now and they're different in the future. So the definition is saying that if the utility of x naught A, which is the same as x naught B, so I'm just going to call it x naught, and then x1 of plan A, x2 of plan A, etc., is greater than the utility of x naught followed by all of the x's for plan B, then it must also be the case that the utility cutting off today, right, stepping forward to tomorrow, ask you the same question, compare these two plans, the utility of x1A followed by the rest of plan A is greater than the utility of x1 in plan B followed by the rest of plan B. Okay? Now you just showed that in one particular instance that's not true for you, for a lot of you, for sort of the representative member of this population, because I gave you a plan I gave you two plans that were exactly the same. You lived your life as if nothing was going to be different for 52 weeks, and then the plans differ, starting in 52 weeks. And time consistency requires that anywhere in that first 52 weeks I ask you, you'll give the same answer about which plan you prefer. And what's actually true is that right about when you get up to the 52nd week, your answer will suddenly change. And you'll say, give me the 100 now. Okay? So this covers a lot of bases, as you'll see over and over again. So because of the exponential discount function, the DU model predicts time consistency always, always, always. And that's precisely because the per period discount factor delta is constant. If discounting is constant, preferences will be consistent. So what does that look like mathematically? It looks like this. If I give you these two plans that you just saw, where x naught is the same in each plan, the utility under DU is the utility of x naught plus delta times the utility of x1A plus for all of the delta squared, and on. Sorry, I better write in that delta squared. Plus delta squared times the utility of x2 in plan A. If that's greater than that same instantaneous utility of x naught plus the discounted future utility of x1 in plan B, delta squared times the utility of x2 in plan B, right? And basically what I can do mathematically in the DU model is I can just say kill these things, right? And then divide by delta, and I can do it up through the entire chain, and what I get is u of x1a plus delta times u of x2a, etc., is still going to be mathematically greater than u of x1b plus delta times u of x2b, etc. Okay? Because delta is constant over time, I can just hack off whatever part of the two plans are the same, divide by however many deltas I need to, and I will get the mathematical representation of how you will feel about these two plans one period forward. Okay? So the first line up there is a mathematical representation under Samuelson's model of how you feel about these two plans today. The second line is how you will feel about them tomorrow, and since they didn't differ today, your preferences shouldn't change. And that's because of the exponential discount thingamajigger. And if your preferences do not satisfy time consistency, you will exhibit preference reversals. Now, let me just ask you guys, this is just a guess, ask you to make a guess. There's an infinite range of possible discount functions that you could imagine, right? The exponential function is just one. It could be some hyperbolic function. It could be some step function. It could be absolutely anything as long as it's decreasing over time. Guess how many alternative models of the discounting function there are in the entire universe of mathematical functions, analytically representable or not, that also have this time consistency quality or characteristic. Anybody want to guess the number? Exactly 0. This is literally, and this was proved by Strauss in 1955, I think, in that paper's online. Literally any other discount fact function will generate time inconsistency. We have what's 2014 minus 1937. It's a lot of years we've been using religiously, almost literally, a discount fact function that is what is like this infinitesimal knife edge case. There's only one possible discount function that delivers this result. And because we like consistency and rationality so much, and because we dislike reference reversals so much, we've clung to this model, right? It's extraordinarily unlikely that human psychology is actually represented by one function out of an infinite set of possible functions. Okay. So we've seen that your preferences don't satisfy time consistency. What does that mean? It means a series of things. It means, first of all, we know already that the standard discounted utility model cannot explain observed results. We have an anomaly. We will see plenty of other anomalies. It means that individuals exhibit preference reversals, which is a form of irrationality. So there's an anomaly, and in particular that anomaly is a case of irrationality, and apparently the discount factor, the per period discount factor, changes depending where we are in time, and next lecture that will make a lot more sense. I'm going to skip these questions to contemplate because they're not super central, and go on to the last bit of this lecture, which will sort of tee things up for lectures to come. So on your own, I'm going to go just with the assumption that all of you, to a first-order approximation, would in fact be patient if these outcomes were delayed a year. So let's just assume, and if that's not the case, right, I'm going to assume that you would choose $105 in 54 weeks. If that's not the case, sit this Klecker question out or just press some button to get participation points, and also then come to my office hours so we can talk about your preferences and how they're going to affect your future. Now, this is a little tricky, so let me explain what I'm doing here. Suppose that you knew that in 52 weeks, instead of being bound to your choice of waiting an extra 2 weeks for the additional $5, you were suddenly given the opportunity to reverse your decision. Okay? So that the decision you're making now is not actually binding. Okay? Which of the following 3 plans would you prefer? To go ahead and stick with, no, I'm gonna go with $100 in 52 weeks, or I'm gonna go with $105 in 54 weeks, right? And you choose these things and the other one becomes sort of off the table, except that you know it's gonna be put back on the table. Or would you prefer a third plan in which you receive $104 in 54 weeks, so basically paying $1, but to have that option to change your mind taken off the table? Okay? Yeah. Oh, you can stick with your choice a year from now. So you could choose the 105 now, and then a year from now you could choose the 105 again. Or you could make a different choice now, which is to go with 104 in 54 weeks and be locked into that choice. Okay? Have your future choice taken away from you. Go. Okay, 5, 4, 3, wait, pick it back up, 2, and click it, 1. Okay, fine. All right. So the vast majority of you said that you would just go ahead and say, no, I don't want to pay that buck. But there's a decent chunk of you, 31 of you, 19%, who said, I would pay the $1 to basically bind, well, that's right, you can't write on that. I would pay the $1 to bind myself. Now, be honest with me. How many of you chose C here, but at the beginning of the period said that you would advise your client to not bind themselves? Okay? How many of you said here that you would not bind yourself at cost, but in the beginning of the class said that you would advise your client to bind themselves? Okay? What's up there? You think you're so much better? Okay? I got information for you, and we're going to study this at length. You're not. You're not. Okay? And we're going to talk about that. So I'll actually finish up this last slide next time. And I'll see you on Thursday.